In this video, I'm going to do a practice test for Unit 2 or Chapter 2 in the Functions 11 course on polynomials and rational expressions. So hopefully you've downloaded the test or you're going to freeze frame and try the questions yourself because the only way to learn is to do, right? Okay, so here we go. Expand and simplify. 3 and 4 in these brackets, these are just my marking scheme. So A would have been 3 and B would have been 4 marks. Okay, so when you're expanding something with multiple brackets like this, it's often a good idea to try to read what the question says before you begin. So this says I have 4 times 2x minus x minus 3. And look how this is in brackets, right? So you want to work from the inside out and you want to be removing the brackets. So we're going to do the 4 last. We'll leave the 4 here. And here I have 2x, and now I'm going to get rid of this bracket by multiplying everything by the minus sign in front. So minus x, and a minus means plus 3. Okay, so you can see now that I've removed this big bracket, and now I'm going to simplify that later and multiply by 4. Same thing with this one. I have 5 out front. So let's leave the 5 there, and I'm going to simplify what's in here. So I have 3x, and I have x times what's in the brackets here. So that's plus 2x squared plus 7x. Okay, so now in my next step, I'm going to simplify this just in my head. So 2x minus an x is 1x. So I have x plus 3 here, all times 4. So x times 4 is 4x. And I have plus 3 times 4, that's plus 12. And here now I'm going to reorder it. So I'm going to put it in descending order. So highest exponent here is squared. So I'm going to do 5 times 2x squared is 10x squared. And then I have a 3x plus 7, that's 10x's times 5, so plus 50x. And finally now I'm going to gather my like terms. So I only have 1 to the power of 2, so 10x squared. And I have 50 plus 4, that's 54x, and then plus 12. And there you go, 3 easy marks. You can do it. Okay, with letter B here, it's worth 4 marks, so there must be something a little trickier here, and it involves expanding. So I have a binomial squared here, and I have a binomial times 3. So again, I would leave the 3 out front. You could multiply the first bracket by 3 and then expand it, but I find students tend to over multiply by this 3, like they'll do 3 times this one and then times this one, and then you end up with the wrong answer. So let's leave the 3, and we're going to expand this binomial times a binomial. So x times 2x is 2x squared. Then I do x times 1, that's plus an x. Minus 7 times 2 is minus 14x, and minus 7 times 1 is minus 7. Okay, now don't worry about doing everything in one step. You've got lots of paper here, and sometimes students just try to skip steps and then make big mistakes. So we have a minus sign here, and again, the minus signs are like stop signs in math because you know that you're going to have to change the sign of everything in this bracket eventually. So I'm going to leave the bracket here because I'm squaring a binomial. So I square the first term, that's 9x squared, twice the product. So minus 3x times 2 is minus 6x, and square the last term, plus 1. The most common mistake squaring a binomial is to say this is 9x squared plus 1, right? You forget the middle term. So remember, when you're squaring a binomial, you square the first term, you take twice the product of the two terms, and you square the last. Or you write it out twice, right? You write it out like this, 3x minus 1 times 3x minus 1, and you do your binomial expansion. If you followed me since grade 10 or even earlier, maybe in this lesson, I've talked about square twice the product square, which is the way I learned it way back some 50 some years ago. It still works. Math is just great like that, isn't it? Okay, now I'm going to try, well, maybe I'll be very cautious here because that way you don't make any mistakes. plus x minus 14, so that's minus 13x minus 7. Okay, so everything's fixed up there. And here, I'm just going to, I have nothing in the brackets here that needs to be put together, like they're all different terms. So I'm just going to multiply everything by the negative. So negative 9x squared. Negative times a negative is a positive, and then a minus 1. And then I'm going to multiply this by 3. So it's going to give me 6x squared minus 39x minus 21 minus 9x squared plus 6x minus 1. And then I'm going to gather like terms. So I have 6x squared minus 9, that's minus 3x squareds. Minus 39 plus 6 is minus 33. And finally, the constant, minus 21 minus 1 is minus 22. And there, you're off to a great start on your unit test. Now the factoring. Okay, so hopefully you've got your factoring skills polished up. If not, go back and look at some of the factoring skills that I covered, or you could go back as far as a grade 10. Maybe some of you might have missed some of those lessons and get yourself really sharp on factoring. It's a critical skill for grade 11, grade 12. You know, it doesn't go away. Okay, so this is a simple trinomial. Note that the coefficient of x squared is 1. So I'm looking for two numbers that multiplies. Remember, you do product of minus 44 and a sum of minus 7. So I'm going to do it the long way because I don't want to make a mistake. And the same two numbers add together to give me minus 7. So 44, I know right away just by looking at it that's 11 and 4, and I can make a 7 out of an 11 and a 4. So I put 11 and 4 here, and then I determine which one needs to be negative. Well, because the sum is negative, that means the larger one needs to be negative. And there's your two factors here. So we're going to have x minus 11 and x plus 4, and you're done. Letter B here obviously is a difference of squares. So on each side of this minus sign, I can take the square root. So the square root of 81x squared would be 9x, and the square root of 1 is, of course, 1. And then you just write it in the two brackets, 9x plus 1 times 9x minus 1. That was way too easy, wasn't it? Letter C, 14x cubed y to the 4th minus 21x to the 5th y squared. Well, this isn't a trinomial. It's not a difference of squares, but there is a common factor. Remember that when you're factoring, the first thing you always look for is a common factor. So looking at the coefficients here, the numbers, the 14 and the 21, what is the largest number that divides into both of them? And you should say, yes, I know that is 7. So you can take out 1 7 from both of them. Now you look at the x's. This one has 3, this one has 5. So the most I can take from each term is 3. So I put x cubed. And y to the 4th and y squared, so the most from each would be y squared. And now I divide each of these terms by this number that I've pulled out. So 14 divided by 7 gives me 2. X cubes, well, they divide out. Y to the 4th, y squared. And you can double check by expanding, right? 14x cubed, y to the 4th. Good. And now into minus 21, I would go minus 3 times. This had 5 x's, this is 3, so I still have 2 in the numerator, and the y's are gone. And there you go. You're done. It was a common factor question. Okay, letter D, x to the 4th minus 10x squared plus 9. Well, you might be saying, oh, well, this is a 4th power. How does that work? Well, this one is going to work the very same way as if you were factoring a power of 2, because this is half of it, right? So if you're unsure, then you could say, okay, well, let's just pretend these are squared in an x, and I'm going to factor it by looking for a product of 9 and a sum of minus 10. And obviously that's going to be 9 and 1. Which one is negative? Well, they're both negative because the product is positive. So minus 9 plus minus 1 is minus 10. Okay, so minus 9 and minus 1. So if I just put here x minus 9 times x minus 1, you can see that I would get the 9 right, but I wouldn't get these right. So if I put squared here, all of a sudden it's solved. X to the fourth minus an x squared minus 9 is minus 10x squared and plus 9. And there you go. Okay, second page. Well, if only you could do it this fast on your test, right? Factoring continued. Okay, so we have 16x squared plus 24x plus 9. Okay, now obviously this is, it's a complex trinomial, but if you look at the first and the last terms, you can take the square root of them. So that should make you think that it's kind of a special trinomial. So this one is 4x. The square root of this would be 3. And 4 times 3 is 12 times 2 is 24. So it's a perfect square trinomial. And it will factor to 4x plus 3 times 4x plus 3. And you shouldn't leave it like that. You should leave it in its most simple form by saying 4x plus 3 squared. Okay, letter F. So this one, we have 4 terms. When you have 4 terms, and make sure yours says plus 12 here in the end. I'm not quite sure in the text if I fixed it. When you have 4 terms, it's normally factored by grouping. It could be factored by grouping, or it could be factoring, well, we'll look at the next one in a minute, but this one is factored by grouping. So if I looked at these first 2 terms here, I would say, well, what can I take out of both of these? And sometimes you have to play around with them. It might be these 2 and these 2, or in this case, I'm just going to do these 2, and then I'm going to do these 2, because I can see right away that if I take out an x squared out of these 2 terms, I would have 2x minus 3. And look, 2x minus 3, I just have to divide by minus 4, right? Minus 4, and that's going to give me 2x minus 3. And now these become the common factors, and you're left with x squared minus 4 times 2x minus 3. Now don't stop there, because this is still factorable, right? We have another difference of squares here to deal with. So I have x plus 2 times x minus 2. When you're asked to factor, it's factor completely. And there you go. Okay, letter G. Now this is the one I'm talking to you about that has x squared, a y, and a minus 9. So if we look at this, it's not going to be a factor by grouping because there's an x in here. But this is a nice little trinomial on its own, isn't it? Now, you have to kind of play with these and get used to seeing these types of patterns. But if I take out a minus sign from each of these, because when you factor, of course, you want the coefficient of your power of 2 variable to have a positive value. So I'm going to make these all change signs. And now I have something here. Oh, I forgot the squared. I have something here to factor, right? This is a a trinomial, and again, we just did that one up here, didn't we? Except it has a different sign in front of the 24. So this is a perfect square trinomial, 4y and 3, and times 2 would give me negative 24. So the only difference from this one to this one is that I'm going to put in 4x minus 3. So 2x squared minus bracket 4x minus 3 squared. Now, if I was a really clever teacher, I would have made this 4x squared, and then you would have a difference of squares, right? Let's say it was, just because your teacher might give you one that looks like that. So let's say this started as 4x squared, and after I factored it, I had this. Now you can see that this is a difference of squares, right? And that's usually, well, not usually, but sometimes what can happen. So the square root of this is 2x, so I would have 2x plus, and the square root of this is just what's in the brackets here, right? If I take the square root of this, I end up with 4x minus 3. And then I would have 2x minus, now this is where you have to be careful because it's going to be minus 4x plus 3 because it's minusing everything. And then I would just simplify this. That would give me 6x minus 3 times minus 2x plus 3. So that would have been a better question if this started with 4x squared. Okay, I'll just put that over here because this is the right answer for this one, but this now would be that. And that's a common question you did in your homework. Okay, number 3, simplify and state restrictions. Okay, so the big thing here to look for is what am I doing? I'm adding, I'm subtracting, I'm multiplying, I'm dividing. So teacher wants to know, can you do all these 3 types of operations? When you are adding, the thing you should be thinking about is common denominator. So I look to the denominator here and I see that, well, these aren't common at all. So I have to make them the same. So I'm going to leave some space here so that I can show you what would be a common denominator here. So if I did a 5 and a 2, the lowest common factor here of 5 and 2 would be 10. So if I put a 10 down here, I had to multiply this by 2. So I'm going to put a 2 up there. Okay, and I multiplied this by 5, right, to get 10. Now I need an x squared and a y squared. That's going to be my common denominator. 10 from these, x squared because this one has it, and y squared because this one has it. So to make this into 10x squared y squared, I would have had to multiply by 2 and an x squared. So I'm going to put those there. Now over here, I didn't multiply by a lot. I did 10, so I needed the 5. I have an x squared, and I have 1y, so I need to multiply by y. And now I get to expand. So that's 12x cubed plus 15y all over 10x squared y squared. Okay, now the worst thing you can do is try to cancel out y's and x's after you've done this, because this is a plus sign. You can only divide things out if there's multiplication happening, so just leave that alone. Now you also need to state the restrictions. Restrictions are what makes the denominator 0 here. So x cannot be equal to 0, and neither can y. And you do that from looking here. Okay, letter B. X, I'm subtracting this time, so again, I still need common denominators. Now, the problem with some students is when you see these, you forget that this is all together. This is like a little family. I can't just say, oh, I'm going to multiply this by a 5, and that'll give me 5x, and I'll add 2 to that one. No. These are like little families. So if I have 5x and x plus 2, that's going to be my denominator, 5x times x plus 2. And now that's easy to fix these because 6 needed an x plus 2, and I'm subtracting a 4, and to make this common denominator for this one, I need to multiply by 5x. Okay, let's do the restrictions right now because we can look at them here. So x can't be equal to 0. And what would make this denominator 0 when x is minus 2? You can set it equal to 0 if you want, but I think that one's pretty obvious. So x cannot be equal to minus 2. And don't forget the not equal to. That's your restriction. Okay, I haven't finished this though because I need to expand. So 6x plus 12 minus 20x. Leave the denominator alone. That's why you did it. 5x, x plus 2. And 6 minus 20 is minus 14x plus 12 all over 5x times x plus 2. And I didn't leave myself much room, but here's my restrictions up here. Make sure you put it very clearly for your teacher because teachers have a hard time finding answers sometimes because students tend to hide them. Okay, I used to have a student that would put like a little box over her solution, and I kind of liked that because it was easy to target it. And also, if you make a mistake in here and your teacher sees the right answer, they might just not see your mistake. That's a bad thing for me to tell you, right? Okay, this one here, we are multiplying, multiplication. So in multiplication, things get divided out from top to bottom, right? You can divide things out. So if you look here, sometimes they get really messy because, you know, like this goes into this one and this divides by 9 and this divides by 9. I think it's better if you simplify the top first because it's really easy to do. Watch this. I'm going to leave the 27 times 5 because I know these are going to divide out, right? This is going to go into here and this is divided by 9 and this will be divided by 9. And how many x's do I have? Well, I have x to the 5th power because 2 times x squared times x cubed, and y times y is y squared. So this kind of makes it a little easier to see what's happening here. So I'm going to leave 25 times 36, which is just the coefficients here. How many x's do I have? Well, I have an x cubed, and I have y to the power 5. And now it'll be so easy, and I won't get lost in crossing things out, which happens from time to time. So this 5 will go into this 25 5 times. This is divisible by 9, and so is this one. And now my number in the top here is going to be 3. And x's, well, this has 5, this has 3, so this will make this a 2. So I have an x squared. And the 5, the higher power is in the denominator here. So that's going to be in the denominator as my y cubed, 5 minus 2. And 5 times 4 is 20. And there's my answer. Now, what are the restrictions? Well, in this case, x and y both cannot be equal to 0. They're just all multiplications here. So if x was 0, this would be undefined. And likewise for the y. Okay, letter D here. I'm dividing. Okay, always check this sign. Make sure you know what you're doing. So when I divide, I'm going to invert and multiply. So I'm going to check here I'll write it up like this. And I'm also going to do some factoring while I do it. So 28x plus 4, I can take out a 4, and that would give me 7x plus 1, right? 7x plus 1. I'm going to write multiplies. And I'm going to flip this, and I'm going to factor out a 5 from these two terms. And look, they happen to give the same factor as the other one, over 6. Okay, so the 6 goes into 6. They go in one time. You could put the 1 there, 7x plus 1, 7x plus 1. And wow, look, I've got the whole question down to an answer of 5 over 4. Okay, so now in addition to being 5 over 4, I need to know what the restrictions are. So if I set, well, better to look at once it's factor here, 7x plus 1. So just solving 7x plus 1 set to 0 would give me -1, -1 over 7. So x is not equal to -1 over 7. And that's for both of these. Now remember, if you were dividing, you would have to look in the numerator and the denominator of this side, but this is a constant, so it's not a restriction. Okay, let's go on to the next page. A little bit longer question here. Something to factor, numerator and denominator. Okay, so let's factor this up. What have we got in the top? Is this a perfect square trinomial? Is 1 times 7 times 2 14? Yes, it is. So that gives me x, but there's also a y squared and an xy in the middle. Don't let it bother you. Like, I have so many students that see that and they go, what do we do? So this is going to be x plus 7y squared. Now watch what happens. If I square this, I get this one. Twice the product would be 14xy, and square 7y, I get 7y squared. Easy as that. This is obviously a difference of squares. That's going to give me x plus 7y times x minus 7y. And I have two of them up here, one down here. So this one cancels out. That makes 1 in the top. And I have x plus 7y over x minus 7y. And please, again, do not cancel out these x's. This is a complete family here, not to be separated ever, ever. Okay, what are the restrictions? Well, what made the denominator here is 0? So I have x plus 7y, so x cannot be equal to minus 7y, and x cannot be equal to, for this one, plus 7y. And you're done. Okay, now this question, there was this one that I had on this test, and this one is on your test, so this is the one I'm going to do for you over here. You can write this one out and try it on your own if you want. Okay, so this is times, and then it's minus. So you have to know your order of operations. Make sure you do the multiplication first, and then you do the subtraction, okay? So it doesn't matter if I put the multiplication down here and the subtraction here. You would have to do this part first, right? So watch where your signs are. So I know this is going to involve some factoring of terms. So I'm going to leave the 12x. It's multiplication, so I don't have to flip anything. And in the denominator here, it's not a trinomial, but there is a common factor of 4x, right? 4x, do you see that? Comes out of both of these. So that's going to give me x plus 5. Double check, always double check your answer. Make sure you didn't make a mistake. And I'm multiplying by 25 minus x squared. That's a difference of squares, so it's going to be 5 plus x times 5 minus x. And don't forget this part of the question is still going to be here. We're just not going to do it right away. And what did we have in the denominator here? Oh, we have a complex trinomial because the coefficient is not a 1. So I'm looking for a product of minus 10 and a sum of minus 9. I think I gave that in the question previously too. Boy, my test was too easy. Unless you got them both wrong, right? Get it wrong twice. So sum of minus 9, so it's going to be minus 10 and plus 1. Minus 10 plus 1 is minus 9. And so my two special numbers, I'm gonna still write them over here. So I have minus 10 and 1. And remember to put them over the coefficient of x squared, which is 2. 2, 2. This gets reduced to minus 5 over 1. And this stays, can't reduce it. So this is my x on the bottom, the other on top. I did a whole lesson on factoring complex trinomials. Okay, so that's going to give me x minus 5 times 2x plus 1. Okay, so I'm still just looking at this part here, right? I want to simplify this before I do this part. So what can I divide out? Well, x plus 5 and 5 plus x are the same thing. Always check. If I put in a 1, I get 6. Put a 1 here, I get 6. Yes, they are the same thing. Now, a 5 minus x and an x minus 5, are they the same thing? Well, put in a 1. I would get 4. Put a 1 here, I would get negative 4. So that means they're kind of the same, but they're off by a minus 1. So we divide into each other minus 1 times. Now here I have 12x and 4x. The 4x will go into 12x 3 times. So that's going to give me 3 times negative 1 is negative 3 in the numerator. And in the denominator, I'm left with 2x plus 1. And now I'm going to subtract x minus 3 over 2x squared minus x minus 1. Okay, nothing to do with this one, but this one, I need to factor it. So I'm going to put it over on the side here. I'm looking for a product of 2 and a sum of minus 1. 2 numbers multiply together to give me 2. Same 2 numbers add together to give me negative 1. So the sum is negative, the product is positive, so both of them have to be negative. Oh, that's not going to work. Product of, oh, it's a product of minus 2. That would help. Product of minus 2, sum of minus 1. Okay, so that's minus 2 and plus 1. Minus 2 and 1. And the coefficient is 2. So this is a complex trinomial, so I make two fractions with the first number on the bottom, reduce, and then you can stop. So this one's done. This becomes minus 1 over 1, and that will be my x on the bottom. So that's going to give me minus 3, 2x plus 1, minus x minus 3 divided by, I have x minus 1 times 2x plus 1. Okay, now in order for me to finish this, I have to make a common denominator because I'm subtracting. If you're subtracting or adding, you need a common denominator. So the common denominator is going to be x minus 1 times 2x plus 1. Right? I had this one, but this one is missing this one. So if I multiply this by x minus 1, I multiply the top by x minus 1. And I'm subtracting all of this. This is where you have to be careful, right? This is minus all of this. So this is going to be minus x plus 3. And I'm going to expand this, so that's minus 3x. Oh, I'm going to do it all in one step. Minus 3x minus an x is minus 4x. Minus 3 times minus 1 is plus 3. Plus 3 more is plus 6. And in the denominator, I have x minus 1, 2x plus 1. Okay, so that's all very pretty. Now you could still factor out a common factor out of the numerator here. It depends on your teacher. Some teachers kind of like that stuff, you know. So I'm going to take out a minus 2, and that's going to give me 2x minus 3 over x minus 1 times 2x plus 1. And I'm finished. Okay, now what were the restrictions? Oh my goodness, we had so many things going on here. So here's one of the denominators, this one. So that's going to give me x is not equal to minus a half. With this question here, we had, up here, sorry, we had x minus 5. So that means x can't be equal to 5. We had x plus 5, so x could not be equal to negative 5. And anything else, this one here, right, we had this x minus 1, so x cannot be equal to 1. So anytime there's anytime you have factored denominator, you have to check all the things that could make them 0. So I had minus a half plus 1, minus a half here again. I had 5 and minus 5. Oh, we had another one here. X cannot be equal to 0. Right? 4x. Don't forget that. What x value would make this denominator 0 when x is 0? Okay, that was one big long question. And we're on to the back page. Hooray, hooray. And this question says, for the following, state whether there is a hole in the function and or an asymptote. If there is a hole, give the coordinates of the hole. If there is an asymptote, state the equation of the asymptote. And for bonus marks, sketch it. Yeah, we can do all of that. We can do the bonus mark and everything. Right? Okay, so let's factor this. Okay, so we have x minus 4 in the top. Leave it in brackets. In the denominator, I have an x plus 4 times x minus 4. Now remember that in order for there to be a hole, it means one of the values for x here that makes the denominator 0 will also make the numerator 0. And that would be 4, right? If I put in a 4 here, I'd have 0 over 8 times 0, 0 over 0. So that means a hole. And that's an H-O-L-E kind of hole. A hole when x is equal to 4. Because this is going to divide into this one. And what I'm going to be graphing is 1 over x plus 4. Okay, what is the asymptote? So the hole is going to happen when x is 4, but I also need to know the y-coordinate. So when x equals 4, we have a hole, but it's going to approach the value of 1 over 8. So f at x is going to be 1 over 8. So 4 and 1 over 8 is the whole, the coordinates of the whole. Coordinates of the whole. Now the asymptote, there's a vertical asymptote. That means what makes the denominator 0? In this case, it's negative 4. So x equals negative 4 is the asymptote. And you should say vertical. Vertical. Now you know 1 over x plus 4, that's the graph of 1 over x shifted to the left 4 units, right? You know that. To the left 4. What makes the denominator 0? When x is minus 4. So I'm going to put my x equals minus 4 here, my vertical asymptote. And I know that if I put in 4 and 1/8, so this function is going to go like this, you know, because the 1 over x graph, of course, looks like this, right? So the only transformation that happened here is a shift to the left 4 units. So it might be nice to know where I'm going to cross the y-axis, because I know that when I'm out at 4, so let's put this as 4 here, 4 and 1/8, so this is the coordinates 4 and 1/8, I have a hole, so I'm going to draw that in there. Now what would be this? What would be, your teacher might want you to give the y-intercept. So the y-intercept happens when x is 0. When x is 0, I would have minus 4 over minus 16. So that's 1/4. This is 1 over 4 right here, where it's going to cross the y-axis. Now, as x approaches infinity, we have a horizontal asymptote here. So this is y equals 0. And the other is just going to go like that. Very nice. Done. I have my hole, I have my vertical asymptote, and I've graphed the function and stated where the hole is and where the... Don't just say the hole's at 4, because you need a y coordinate. Okay? And the last question. The two equal sides of an isosceles triangle. Okay, remember, isosceles triangle, 2 sides equal, have a length of 4x plus 1 minus 5. 4x plus 1 minus 5. This is 4x plus 1 minus 5. Okay, good. The perimeter, that's the distance around, is 10x plus 4y minus 18. So perimeter equals 10x plus 4y minus 18. Determine the length of the third side. Okay, so if I told you that I had an isosceles triangle, the perimeter was 12 and this was 3 and this was 3, you'd say, well, 3 plus 3 is 6 from 12. That means this is going to be 6. 3, 6, and 6 is 12. So if you know the way all the way around, you would have said, if I called this Z, if I told you the perimeter was 12. Now, sometimes it's a really good idea to make up these little examples just to get it straight in your head what you're doing, right? So I'd say, well, 12 plus 2 times 3 is going to be Z. Sorry, 12 minus, no, plus, it was a perimeter. Okay, so that means that 4x plus y, or 2 times 4x plus y minus 5, 2 of these subtracted from this, right? This plus z. Let's call this z. No, but I was right. It was supposed to be subtracted. So I have 2 of these plus z is going to be this, 10x plus 4y minus 18. Or I could say z is going to be equal to, I'm going to write it out again, 10x plus 4y minus 18. That's the whole perimeter, so I'm going to subtract 2 times this. So 2 times this is going to be subtracting 8x plus 2y minus 10. Now don't forget, see, I put it in brackets because if I didn't, I would have forgotten that I had to change the sign of all of these other terms. So I'm going to have 10x plus 4y minus 18 minus 8y minus 2y. Oh, sorry, that was supposed to be an x. around. I changed variables here on you. So minus 8x, 4x, y, and blah, blah, blah. Okay, minus 8x minus 2y plus 10. Okay, now all we have to do is gather the like terms. So 10 minus 8 is 2x. 4y minus 2y is 2y. And minus 18 plus 10 is minus 8. And there you go. So we've done the whole test now. We've simplified. We've found the answer here. I just want to double check to make sure I didn't make a mistake for you somewhere. Nope, got that right. I just made this little mistake over here. Must have been falling asleep. I did a long 12-kilometer cross-country ski this morning, so I'm a bit tired. Okay, so hope that helps you out. Make sure to subscribe if you haven't. Give me a thumbs up. Give me a little message if, tell me how things are going, or if you need some support or you need someone to tell you that they still love you. I'm here for you, and I hope you're doing really well on your grade 11 functions. Bye for now.